Okay, so now let's look at section 8.4 and 8.5 that deal with the surface area and volume of a cone. So I have the surface area formula and I have the volume formula. So let's have a look at the surface area for a moment. This is pi, which is approximately 3.14. Your textbook actually uses the pi button. If you use 3.14, it's fine, but know that your answers might be slightly different than the back of the book, okay? R is the radius of the circle because a cone has a circular base, okay? And this S is the slant height. It's not the height of the cone, it's the slant height. So if I look at this diagram here, this 24 is the height of the cone. This is the height of the cone, which is 24 centimeters. This part right here, this is the slant height. So this is your S value. Okay. And then you're going to add pi, and then you're going to take your radius squared. So let's have a look at what we have here. Okay, so this 10. Okay, so I'm just going to redraw at the bottom for a moment. There's my circle. Okay, and this is 10 centimeters. So this 10 is the radius. Now be careful because some problems will actually give you the diameter. Okay, but this one doesn't. It gives you the radius. Okay, so make sure you pay attention to the diagram. Okay, so I know my R value is 10. Now I know my height of my cone is 24, but in order to use the surface area, I need to know the slant height. So once again, I'm just going to redraw this part right here. Okay. Hopefully, once again, you notice that you have a right angle triangle. So my height is 24. My radius is 10, and these are in centimeters. Now I need to find my slant height. Okay, this is a 90 degree. So hopefully you remember the Pythagorean theorem. Remember the Pythagorean theorem whenever we're looking for a side length of a right angle triangle. Once again, across the right angle is your hypotenuse, which is my slant height, which I call A, which I call B, does not matter. Okay. I'm going to call A 24, B 10, and now I just use my order of operations, 24, and I square it to get 576. 10, square it to get 100. I add those together to get 676. And remember, you need to now square root that because this is S squared. Now we find S. So square root 676, and we get 26. Okay, so I'm going to need this for my formula. So you're going to have to, if this isn't given, you find it first. Okay, so now I'm going to find my area. I'm going to use pi. I'm going to use the pi button on my calculator. I know my radius is 10. I know my slant height is 26. Okay, then I'm going to add pi, and then I'm going to take my radius and I'm going to square it. Okay, so now I'm going to simplify by multiplying, simplify by multiplying, but of course we're going to have to do the exponent first. Okay, so I'll just do that exponent first. Okay, which I know is 100. Okay, so now I'm just going to multiply this. So I'm going to take my pi, and again I'm going to use my pi button, times 10 times 26, and I get 816.81408999, and then I'm going to take pi, I'm going to times it by 100, and I get 314.1592654. I add them together. Now the question asks me to round to the nearest nearest hundredth. Okay, so remember, the near hundredth is how many decimal places? It is 2. So when I answer this question, I'm going to round to 2 decimal places. Now remember, your units are important because this is in centimeters. You're going to write centimeters. Because this is area, it's centimeters squared. So I'm finished the surface area of the cone. Okay, now let's look at volume. Now volume, you're going to take pi, you're going to times it by your radius squared, multiply it by your height, and then divide it by 3. Okay, so once again, I'm going to use my pi button. I know my radius is 10. I'm going to square it. The question gave me the height at 24. Remember, that was given. And then we're going to divide it by 3. So once again, you're going to do BEDMAS. So you're going to do the exponent first, which is 10 squared, which is 100. Okay, now at this point, I can do everything in one step. I'm going to take pi, I'm going to multiply it by 10, then I'm going to multiply it by 24, and then I'm going to divide it by 3. Okay, in that order. So pi, multiply it by 100, times it by 24. This means division by 3. And again, I'm doing this to the nearest hundredth, which is 2 decimal places. So 2,513.27. And because it's volume, now it's centimeters cube. And that's how you use your 2 formulas. Okay, so let's look at some application questions. Okay, so let's look at this one here. So again, here's your diagram. Okay, and you're told that an ice cream store offers coated cones, and you're given this. Okay, the cone is open top, right? Because remember, it's an ice cream. So the top here does not have any, like, it doesn't have an opening because, it doesn't have a top to it. It's open because ice cream is going to fill into the cone. Okay, so that's what it means by open top. The entire outside is coated in chocolate. The top part is not, because remember, it's open and you're going to be filling that with ice cream, and you're asked for the surface area. Okay, so I'm going to rewrite my area formula. And let's have a look at it for a moment. Remember, surface area is the area of all the faces. So this part here is this here of the cone. Okay, that's called the lateral surface. And this part here is the top of the cone. Okay, because pi r squared is a circle. Now, if there is no top to this cone, if they've taken that top off, I do not include this in my surface area formula, because remember, the top is open. So this is the part, this lateral surface around the cone. This part here, I'm going to just kind of highlight it. This is the only part that is coated in chocolate, right? All around, not the top, because it's open. So this is the only part of the formula that I'm going to be using. Okay, so once again, you look at what you've got. Here you have the radius. This 10, is this the height of the cone, or is this the slant height of the cone? The 10 is the height. So once again, I need to, in this example, figure out what my slant height is. Sometimes you're given the slant height, sometimes you are not. So pay attention to what you have. Okay, again, this is, the S is my hypotenuse. Once again, I need to use the Pythagorean theorem. Which you call A, which you call B, does not matter. Follow your order of operations. Okay, then you're going to square root 136. It doesn't tell you how many decimal places to go to, so what, just, 1 or 2 decimal places would be appropriate. So I get 11.66190379. I'm going to do this to 1 decimal place. Okay, now this is where sometimes people make their mistake. If you're doing it to 1 decimal place, remember you must look at the decimal place to the right of it. Because this is 6, so anything 5 or more, you need to add 1 to this 6. If it was under 5, then you would just leave that 6 alone. So this is approximately 11.7 centimeters. So this is what I need for my area, okay? So now I'm going to use my area formula. Pi times my radius, which I know is 6, times it by my slant height, which is 11.7. Okay, so pi times 6 times 11.7 is, and again, I'm going to do this to 1 decimal place, 220.5, and this is in centimeters squared. Okay, and because this is an application question, I answer it in a statement. Therefore, the area coated in chocolate is 220.5 centimeters squared. Okay, let's look at one more application or problem solving type question. Okay, let's have a look at this one. Okay, so once again, I have a diagram here. Okay, so what we have is a cone with a top portion removed. So this part here is removed, okay, the part that's dotted. And it says determine the volume, and you're asked to show your work. So I'm going to write out the volume formula. I'm going to take pi, times it by my radius squared, times it by my height, and then I'm going to divide it by 3. Okay, so let's think about how we're going to find the volume of the figure. Okay, so remember, this top part has been removed. Okay, so think about how you might do that. So one method to do it is find, I'm going to just highlight it, okay? Find the volume of the entire large cone here that I'm highlighting in green. Find the area, or sorry, the volume of that, okay? Then what you could do after that is find the volume of the smaller cone right here, and then take it away, okay? So find the volume of the larger cone, okay, that I've outlined in green. Then subtract the volume of the smaller. Okay, so now with volume, I need the height and I need the radius. So let's look at the larger cone that we have in green. Okay, do we have the height of it? And hopefully you said yes, the height is 12. Do we have the radius? From here to here is 8. So what would the radius be? This is the diameter. So the radius is 4. Okay. Now let's look at the smaller cone for a moment here. So let's look for the radius. Are you given the radius? And if you can see, okay, the radius is 1. So the radius is 1. Now let's look, do we have the height of the smaller cone? So let's look at what you've got here. We know the height of the large cone is 12. Let's look what else you've got. You're given this height right here. It is 9. So what would be left over right here? So hopefully you're going to tell me that you're going to take the larger height, which is 12, subtract the smaller height, here 9, to get a height of 3. Okay, so now you have your unknown measurements. Now let's sub the values in. So pi, radius is 4, square it, times it by your height, which is 12, and then you're going to divide that by 3. Then you're going to subtract the smaller one, doing the same thing. Pi times the radius, which is 1. You're going to square it, times it by its height, which is 3. And then you, of course, divide by 3. So we're going to simplify each of these. Okay, so I'm going to do of course, my exponent first. Okay. Then I'm going to do the same thing here. Exponent first. Now I'm going to simplify this. I'm going to do it in one step. So once again, just like I did with the other one, I'm going to take pi, the first example I mean, pi, I'm going to times it by 16, I'm going to times it by 12, and then I'm going to divide it by 3, and I get 201.06. I'm going to do it to 2 decimal places. It didn't tell me what to round to, so 1 or 2 decimal places would be fine. Do the same thing here. Pi times 1 times 3, and then you're going to divide it by 3, and you're going to get 3.14. Again, I did it to 2 decimal places. Now you're going to take 201.06, and you're going to subtract 3.14, and you're going to get 197.92. The units are in centimeters because it's volume. Volume is cubed. And then you're going to give a concluding statement. Therefore, the volume of the figure is 197.92 centimeters cubed. And that's everything.